So we've seen already how we can organize information using a Venn diagram. But what if we have a lot of data? A Venn diagram isn't always going to be the best thing because we have too many different values going on. So what we want to talk about now is how can I gather and organize this information to display it in a better way. So the first thing we're going to talk about is going to be a frequency distribution. So a frequency distribution is going to be one of these main topics. And what it does is it lists the observed values by the amount of times it occurs. So you might have a range of values and you're trying to see how many pieces of data fall within that range, or you might even have a singular value and you're calculating how many times that singular value occurs. It all just depends on the data you're working with, how big you make these groups, how wide of a variety you have, and how much information you have in general. So let's take a look at an example and we'll walk through and then we'll kind of dissect all of the terminology for this. So here are the shopping times of 10 shoppers at a local grocery store. We want to complete this frequency distribution. It's called grouped, meaning it's a group of values for this data. So what we have are the groups already pre-designed for us. So one things that you can kind of notice, one group is 18 to 22 because 18 is our smallest value based on these shopping times. And then I keep going until I hit that largest value of 37. So we have all of our data ranging from 18 to 37 that's going to fall into one of these buckets. And so all I want to do is figure out how many data values fall within each of these four ranges. So starting with the 18 to 22, looking at my information, we have 2 values that fall in this range. So the frequency is 2 for this particular group. Moving on to the 23 to 27 range, we have 2 pieces of information that fall into this group. Then 28 to 32, we've got 3 pieces of information. And then last but not least, the 33 to 37 is 3 pieces of information. Okay. So in our class, we're not going to talk about how to build these buckets. We're just going to kind of talk about some key pieces of information. But if you're taking another course in the future, you will have to go about creating these particular groups. So the one thing that you have to notice is that we have these lower values, 18, 23, 28, 33. These are called the lower class values. So that group can also be called a class. The lower value in each of these is the lower class value. Then if we consider the larger values, or basically the ending value of each group, this is called the upper class values. Okay. And then one thing to kind of notice between each of these, if you go from 18 to 23, you've added 5. 23 to 28, you've added 5. 28 to 33, you've added 5. And same thing from here to get from one upper class value to the other, you've added 5 each time. So one thing that people are often concerned with is, what is this class width? Okay, and if you were thinking of width, you would think of just this group 18 to 22, and you would think that width would be 4 because that's the difference in those 2 values. But really, to find this class width, we want to take the difference in any 2 consecutive lower class limits or upper class limits. This is our class width. So in this example we have, because you're adding 5 each time to a lower class value or upper class value, that would be your class width. It works out nice in this example because they're nice numbers, but if not, all you do is pick 2 consecutive lower class limits, subtract them. So 33 minus 28 gives us the class width of 5. Same thing if I pick 27 and 32, those are 2 consecutive upper class values. You can do that one as well. So 32 minus 27 is also going to be 5. So to kind of show you why this is our class width too, if I just look at this range 18 to 22, these values are 18, 19, 20, 21, and 22. Those are the numbers that fall in that particular range for those set integer values. So ultimately there are 5 values that fit into this category, which again is why that class width is going to be 5. So I don't look at the group, I look at 2 consecutive lower class values or 2 consecutive upper class values to find this class width, okay? So we ultimately have 3 rules when we're talking about grouping this data. And so I'm going to come back to these to kind of just show you that these rules work. But the one thing to kind of notice is that this range of information is exactly our starting and ending values. The smallest data is 18, the biggest value is 37. So every piece of data is going to fall into one of these categories. So the number one thing is that each piece of data should belong to one of our classes or our groups that we create. The other thing to notice is that each of these holds exactly the same amount of information. There are 5 values. So I don't want to make one group 18 to 19 and then my next one 20 to 30. I want the same size buckets for every single grouping that I do. So all of these should be exactly the same width. The other important thing is it kind of goes back to when we were talking about pie charts. We couldn't make pie charts in every situation because information overlapped. Same thing here. I don't want to take one group and say end this one at 23 and then start my next one at 23. Because then that piece of information that is 23, which bucket do I put in? I don't want it to fall into multiple buckets. So these are the 3 things that we have to keep in mind when we're grouping data. The classes should be the same width. The classes should not overlap at all. And then each piece of data should belong to exactly one class. Okay. So that ties in with not overlapping, but I should have a bucket for every single data value. Okay. Now we have some other pieces of information that kind of come. The nice thing about these is you do get a lot of information and you can create really nice visuals with these frequency distributions. You can also see some kind of key things. So like these, you notice that 3 is the biggest amount I have in any bucket, and these 2 classes share exactly that 3 value. They have the most amount of data. So the class that has the highest frequency is called our modal class. So we'll be talking about mean, median, and mode, but the most data is our modal class. So you're looking for which one has the most information in it. And then if there's multiple that have the most, they can both be your modal class. Now, once we have this distribution, a lot of times what we're going to create is called a histogram. So a histogram displays the frequency using a bar graph. Another way we can display this information is really in the same manner, but instead of using a bar, we're going to basically connect the dots from each of these and create something called a frequency polygon. So this will display that same information instead using a line. So what I'm going to do is I'm going to use this same information that we have, and I'm going to go ahead and show you the different types of graphs from it. So our frequency was 2, 2, 3, 3. Okay. So you can see at the bottom, I have each of these buckets to represent those different classes or different groups. And then the most amount of information or the biggest frequency I have is 3. So it would make sense to make my scale going up by ones. Okay. So for my 18 to 22 group, there were 2 shoppers that fell into this. So I'm just going to create a bar that goes up to the 2 line. My next group also had 2. So I go ahead and draw that bar up to the same line. And you want to try to make your bars exactly the same width if you can. Of course, when you're doing it by hand, it's a little bit harder. The next group goes up to 3. So again, draw that bar straight up to 3. And then our last group also has 3. So we draw a same size bar. Okay. So that is one way we can display this information from a frequency polygon, or from a frequency distribution. The frequency polygon is honestly going to be not much different. Okay. We do have a little bit extra work we have to do, because instead of putting that group down here, we're going to represent the class by something called the midpoint, right? So I'm going to start by just creating the frequency polygon, and then I'll show you how we go about labeling this. So the same information goes on the side. Our most amount of frequency in any one of these is 3, so we'll just go up by ones. Our first group had 2 people. The next group had 2 people. The third group had 3. And the fourth group had 3. Okay. So frequency polygon is just going to connect the dots, so everything is one nice unit. Right? And then what we do is we just drop a line straight to the bottom. And so I need to extend this one just a little bit. And it creates what's called a polygon. So a polygon is just a straight shape, or a shape that's defined by straight edges. So this is our polygon. Okay. So still displays exactly the same information. Right? But now what I want to do is I want to represent my groups down here by the midpoint. So I don't want to write the range that this group is 18 to 22 minutes. I'm going to take what's called the midpoint. So for this, I'm really finding the number that's exactly in the middle of this range, 18 to 22. This one we can technically do by hand, but when you start to get not nice numbers, it doesn't work as well. So the values in this group are 18, 19, 20, 21, and 22. 20 is the one that is exactly in the middle. So we'll actually represent this by 20. But what if your values are like 18.1 to 22.7? How do you find the number that's exactly in the middle? So our midpoint is going to be found by taking the lower class value, adding the upper class value, and then dividing it by 2. So to kind of allude ahead, we're going to talk about finding the mean. That's exactly what this is. It is adding the 2 values and averaging them, dividing it in half. Okay. So to show you with each of these ranges off to the side, we've got 18 to 22. We would go ahead and add the lower class value plus the upper class value and cut it in half. So 18 plus 22 is 40. Divided by 2 gives you 20. So our first midpoint is 20. Our next range was 23 to 27. So again, I take the lower value, add the upper value, and divide by 2. 23 plus 27 is 50, divided by 2. The midpoint of this group is 25. So we represent that group by 25 on the bottom. Next group is 28 to 32. So again, add these together, divide by 2. 28 plus 32 is 60, over 2, leaving us with 30. And then last but not least, our final group is 33 to 37. So add these together, divide by 2. 33 plus 37 is 70. Divided by 2 gives us 35. So 35 is the midpoint. The other thing you might also notice now is to get from one to the other, we are adding 5 every single time, which is exactly that class width, which is again why we use the difference in 2 consecutive lower class limits or 2 consecutive upper class limits to find the class width, not the actual class itself. So really, once you find that first midpoint, you don't have to go through and calculate this average. I really could have said, okay, my starting midpoint is 20. Now I'm going to go ahead and add the class width each time to get the remainder of those values. So completely up to you, but there's a lot of really nice patterns that happen as a result of this. Okay. And then to just tie in that last vocab word, to determine the modal class, if it exists, all I'm looking for is the ones with the most data. And so again, these two classes, 28 to 32 and 33 to 37, have the most data, and they're the same. If by chance this one, say, was 5 up here, then the modal class would just be the 33 to 37 group, because there is one that has the most. But here, from that relative frequency, or that frequency back up here, this is the most amount of data, and it's in both of these classes. So we have 2 modal classes. So there are 2. Those groups are 28 to 32 and 33 to 37, because both of these have 3 datas. Okay. Now, the very last thing we're going to talk about with these frequency distributions is just another name. So we talked about finding the percentage of stuff pretty in detail at this point. We can really do the same kind of thing here. So if you notice way back up, we had 10 shoppers or 10 pieces of data. So instead of just finding the frequency for each of these, I could technically find the percentage that fall into this category. So what I would do then is I would just take each of these and I would divide it by the total amount of data that I have. So if you do 2 divided by 10, you'd see it's 0.2, which is 20%. This would be something that's called the relative grouped frequency then instead. Okay. So the relative frequency distribution is similar to a frequency distribution, but instead of listing the number of observed values, we're really finding the percentage for that category. We just list it out as a decimal instead of that true percentage. So let's try an example. We have a chemical technician that measured the temperatures of 17 different solutions. We want to compute the relative frequency distribution for the data, and we want to round to the hundredths place, which means we're rounding to 2 decimals. Okay. So really for these, what I'd like to do first is I'm going to figure out how much data falls into each of these different categories. So I'm basically finding my standard frequency distribution to start. Then I'll go about and calculate the relative frequency. But again, just to kind of show you, our lowest value is 98, and then our biggest value is 117. So I need classes that start at 98 and end at that value 117, or at least include it. It doesn't need to be the ending value if it doesn't work out as nicely. So if I were to go about and I were to find my class width here, what I want to do is I want to look at 2 consecutive values. So our class width is going to be 103 minus 98, which again happens to be 5 here, okay? So I don't look at one group, I look at 2 starting values or 2 ending values, because again, I can pick any 2 consecutive. The difference in these 2 is still going to be 5. So our class width is 5, okay? Now I'm gonna go ahead and I'm gonna figure out how much data falls into these groups that are given to me. So starting with the 98 to 102 range, we have 1, 2, 3 pieces of data that fall into here. So just off to the side, I'm going to mark that there are 3 data values in this group. Moving on to 103 to 107, we've got 1, 2, 3, 4, 5 pieces of information here. Then if we do 108 to 112, we've got 1, 2, 3, 4, 5, 6, 7 pieces of information. And then finally, 113 to 112 or 117, we've got 1, 2 pieces of data. Okay. So all of my data has been accounted for. I've marked off every single thing. And if I go ahead and add all of these together, 3 plus 5 is 8, plus another 7 is 15, plus 2 is 17. That gives us our total of 17 different solutions. Okay. So this would just be my frequency or my grouped frequency distribution. Now what I want to do is find the relative frequency distribution. So the only difference here is I'm going to take this portion I found that there were 3 out of 17 values that fell into this category. So if I do 3 divided by 17 and I round it to 2 decimal places, the relative frequency is about 0.18, which again means 18% of the data is in this group. For the second class, we've got 5 out of 17 falling into this range, which again, if we round it, would be 0.29. The next group is 7 out of 17. When we divide those two, it's about 0.41. And then finally, our last group is 2 out of 17, which when we divide it is about 0.12. Okay. So if I add all of these together, it should total to 1 to represent 100% of the data. If it doesn't, that means I probably made a slight rounding error somewhere within here. Okay. But again, all it's saying is 18% of the data is in this first group, 29% of the data is in the second group, 41 in the third, and then 12 in this fourth group. So if you were asked what the modal class is here, the most amount of data is 7 in any one group. So the modal class would be this range 108 to 112. And now we really have one more way that we're going to talk about organizing or displaying our data. And this actually, I think, is the nicest of them all. It is called a line plot. So a line plot uses a marker as a counter instead of using a bar. So what we do is we really don't have a vertical axis at all. I'm just having all of my data values 1 through 9 here at the bottom. And what I'm going to do is, based on this data, I'm going to mark above each of these values when I hit one of these. So you could do it a couple different ways. You could start by saying, okay, here's a 7. I'm going to put a mark above my 7. Typically we use an X. Then I have an 8. I'm going to put a mark above the 8. Another 8. So I just keep growing it upwards. I put a second mark above the 8. Another mark above the 7, 1 mark above the 6, and then I've got 4 9s in a row. So I'm going to go ahead and just draw 4 9s, and then I have a single 1. Okay. So that's one way you can go about creating these. If instead you don't like this approach, perfectly fine. What you can do is say, okay, look at my data. How many 1s do I have? I have a single 1. So we'll put a 1 there. Looking at 2s, I've got none. 3, 4s, and 5s, I've got none in my data. Moving on to my 6, I have a single 6, so it gets a single mark. On to my 7s, I've got 2. So I go ahead and put 2 marks above it. On to 8s, I've got 2. And then finally on to 9s, I have 4. Okay. And so you can also see your modal class here is 9. That has the most data above it. You might have ranges at the bottom. It really just depends on the situation that you're working with. Okay? So you want to get some practice writing these, creating these distributions. Again, you're not going to be so concerned with creating the buckets. Those are typically going to be given to you for our class, but do your best just trying to then interpret these pieces of information.